All right, let's look at another example. Let's just say I have two cars and they're tethered to a certain point and they're trying to pull it out. Let's say it's a tree stump or something. And I have one vehicle going off here, and let's say this is 2,000 newtons. Another vehicle pulling this direction, and let's say this is 3,000 newtons. And I know the angle between the two vehicles makes 60 degrees. I want to know what is the actual amount of force being applied to this point, and what direction is it actually getting pulled by that point. Well, this is where the parallelogram method is going to help us. Let me draw this a little larger because 3,000 should be bigger than 2,000. So I'm going to draw a parallelogram. And what's actually happening is it's coming this way. So I'm looking for this angle here, and I'm actually looking for that force here. That's what we're actually looking for, but we're not going to do this like measuring it out or anything like that. So what I'm going to do is I'm going to do a clever little trick. I'm going to pick this to be 0 degrees, and then this to be 2,000, this to be 60 degrees. So really what I'm doing is I'm thinking of it like this. I'm not thinking of it as an angle. I'm thinking this is 0 degrees. So I'm going to say 3,000 newtons, and then I'm going to say 0 degrees. And I want to say that this is 2,000 newtons at 60 degrees. Because I know the distance between them is 60. So I might as well, if I get to pick and choose, I might as well choose 0 to make my life a lot easier. So I'm going to write these into vectors. I'm going to add them, and then we're going to kind of work backwards. All right, so here we go. So let's do 3,000 as a vector. So let's call this force 1 is going to be 3,000 newtons times cosine of 0 sine of 0. That's a degree symbol, not an 8. So this is going to give me 3,000 times, let's see, cosine of 0 is 1 and then 0. So this is going to give me 3,000 comma 0 is my vector for force 1. My vector for force 2 is going to be 2,000, I just cannot write today, times cosine of 60 degrees sine 60 degrees. All right, now from here, where my force 2 is going to be 2,000 times the square root of 3 over 2 and 1/2 from the unit circle. Multiply these out. Force 2 is going to be 1,000 square root of 3 and 1,000. Okay, so I have my force 1 and force 2. Now I want to do force 1 plus force 2 because they're both acting in the same direction. If they're acting in different directions, we're going to subtract them. All right, so this just simply gives me, let's see, 3,000 plus 1,000 square root of 3. So I'm going to have 3,000 plus 1,000 square root of 3, comma, 0 plus 1,000 is 1,000. All right, that is my resultant vector. Now, let's find the magnitude. The magnitude will tell me the actual amount of force being applied to this particular point. So all I do is the magnitude of force 1 plus force 2 is going to be the square root of my x component, 3,000 plus 1,000 square root of 3, quantity squared, plus 1,000 squared. And when you do that, you're going to get approximately 4,358.9 newtons. So that's how much force is actually being applied to that point by these two different vehicles pulling it. They're at a 60-degree angle. Now I just need to find the angle. That's fairly straightforward. We're just simply going to do my theta over my y, arctangent of my y over x. I don't have room to write it all. And once I do that, I end up getting that my angle is going to be approximately 23.4 degrees. So it's getting pulled 23.4 degrees, that angle right there. So this is getting pulled actually in this direction. It's not getting pulled in this direction. It's not getting pulled in this direction. It's getting pulled in this direction, which is 23.4 degrees. All right, from force 1. So that's another application of vectors. Not terribly bad. Now let's look and see how we can break vectors into its components and then move into an even more fun problem. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.